This quick video is going to go over 8.1. So all of the actual examples from 8.1 were done in class, and I'll post up the PDF if you want the PDF with all the answers on there. But I wanted to just quickly go through and re-emphasize what was going to be on the final potentially. So 8.1 was about comparing two proportions. So we had three examples to start with in exercise 8.1.1 that just basically ran us through times when this would be necessary. So if we were trying to see how the proportion of people who improve based on being with a new treatment or an old treatment. So we're going to have the proportion of people who improve with the new treatment versus the proportion of people who improve with the old treatment. And ideally, we'd like to show that the new treatment is better, right? So if we were to set up an alternative hypothesis for this, that would be what we'd be trying to prove. And our null, we'd have to start out with the idea that really the new treatment is the same as the old treatment, that there is no improvement on the new treatment. We also have here the question about physical appearance and being satisfied with it. So again, this time we're comparing that between men and women as opposed to a new treatment and an old treatment. But the overarching idea here is that we have this proportion because we have a yes-no question, whether or not you're satisfied with your physical appearance, whether or not you improve, your symptoms improve. This yes-no question that we can go ahead and get a percentage, and we can get it for two different groups. So we here have our men and women as our two groups, and then the previous one we have the new treatment and the old treatment. So two groups on some yes-no binary categorical variable, and then we should be doing this type of test. We went through a bunch of notation. Most important thing here is really this idea that we're comparing true proportions. We're going to use P in our hypotheses. Otherwise, the rest of it, pretty straightforward. We are eventually going to use the fact that the difference is approximately normal. So we need to be able to kind of move back and forth between how we set up this question here and this being the same thing as looking at the difference being equal to 0. Because if we have a difference, then we can use this formula here centered at 0 with a standard deviation calculated using this formula. So we come here to our first example. This is the one that I said is incredibly important, and you're going to see something very much like it on the exam. I'm meant to be highlighting. And that is because it kind of works us through a lot of part 1, a lot of part 2 as part of this. So we have all of our observations in a table, a nice little contingency table, which we said is going to be on the final. We have our types of variables, explanatory versus response. We have whether or not this is an observational study or an experiment. We have the types of variables. So all of this, every single piece of this is from part 1. And then they have us calculate the sample proportion of success from each group. And this is a part 6 idea, right? We're just doing it twice, once for each group, for the people in group A and the people in group B. This could also easily be written as a sort of probability question. What is the probability somebody from group A beats the threshold? What is the probability somebody from group B beats the threshold? It will be the same question. And then we got into this idea of, well, these two values are different. Are they different enough for us to conclude that, you know, really the true value for B is bigger than the true value for A? I know our sample values are, but would it be true for the whole population if we had that data? And that's when we did our hypothesis test. So the hypothesis test, the piece that we really need to know is this, being able to set up our hypotheses. I like setting it up in this format using the proportion of A equals proportion of B. It's usually how our language works for it. But again, you could also set this up as proportion of A minus proportion of B is equal to 0. And that's how we had to set it up when we went to StatCrunch. Calculating the test statistic and the p-value. These are things that I will give to you on the test, just like you saw in the worksheet I handed out on Tuesday. I'm not going to make you use this crazy formula and calculate this by hand because technically this is when we should be using technology to do this anyways. But we should be able to do steps 4 and 5, making our decision and then writing out that same sentence. This is always going to be, there is enough evidence to conclude there is a difference. right? Something along the lines of our alternative, and the same thing here on the other one between those two proportions. So we did an entire hypothesis test through. I'm not going to redo this. We did this using StatCrunch. I will go ahead and walk through the video. I'll do that. The worksheet I handed out in class is a video. So if you want to see something like this worked out, how it'll be on the test, you can see it in that video. I'm not going to waste my time with it now. What I do want to talk about is this example here, 8.1.4. This was the example we talked about in class when we were doing the review about duality. So we found out the confidence interval for the difference in the two proportions for boys and girls posting online profiles was between 0.0473 and 0.2141. So about a 4.7% to 21.4% difference in those proportions. And this is all centered around the fact that originally we had 57% of boys and 70% of girls. So our sample difference, right, the difference in our samples that we would estimate is 13%. And then we have this plus or minus our margin of error. So we think that 13% more girls than boys have an online profile. If we wanted to actually take our confidence interval, we're 95% confident that girls are going to have 4.7% to 21.4% more online profiles than boys. And that's sort of where we're going. Now, what we care about here is step 2. Does this integral reveal about the difference? What does it reveal about the difference? Is it possible that the proportions are the same? And we talked about this in class. If the proportions are the same, that means, that's our null, right? It has an equal. That means that our difference would be 0. And we just did a confidence interval for the difference. So since 0 is not inside my confidence interval, we get to reject the null. That means the two things cannot be the same. We just said we think 4.7%, 21.4% more girls have online profiles than boys have online profiles. We did not say that they were the same. If we had a negative 1.4 or a negative 0.1 to a positive 2, then we would say, well, we're not sure. It could be boys have more, it could be girls have more. But for right now, we're 95% certain girls have more, are more likely to have an online profile than boys. So this is the piece I talked about in class, both when we did this last Tuesday and this Tuesday when we reviewed.